This is a lesson that we should have done before the STAR test, but we didn't get to it. We've kind of talked about it, but it's basically dealing with radicals. So a radical expression, write this down. A radical expression is in simplest form if. So what are we really trying to do today? Put it in its simplest form. So how do you put it in its simplest form? How do you know? Well, first of all, there can be no perfect square factors. No perfect square factors are in the radicand, and that's basically the radical. Okay? No fractions can be in, so no fractions are in the radicand. And no radicals appear in the denominator. So that's how you know if it's in its simplest form. Okay, so the first page at the top, what we're going to do is use the product property of radicals. So basically, if you can expand this out into what's like can be multiplied to make 32. So who can tell me what can be multiplied to make 32? 4 and 8, but let's go bigger. 16 and 2. So if I did under the radicand, if I did 2 times 16, does that have the same value? Yes or no? Does everybody agree? Are one of these a perfect square? Yes. Which one? So what is the square root of 16? So I could pull that out, and what would have to stay under? The square root of 2. That's called the simplest form. Would it have the same value? Yes. If I type the square root of 32 in my calculator, and then I type 4 times the square root of 2, did they have the same value? So we're not changing the value, we're writing it in its simplest form. So basically it's like going back to 5th grade when you learned how to write a fraction in its simplest form, you're learning how to write a radical in its simplest form. All right, look right here. Does any of these have a perfect square? What else? I'm going to show y'all. So go ahead and pull what's the square root of 9? So I have 3 times the square root of, what does x to the third mean? X times x times x. Are one of those a perfect square? Yep. So if I did x squared, what's the square root of x squared? Just x. So I could pull this out, and I'd have 3x times the square root of x. Do y'all understand that, yes or no? Are y'all sure? Because some of y'all kind of looked like you were confused. Let's see. So y'all understand like the square root of 16 is 4, right? So that means 4 times 4, you would take that and pull 1 4 out. Does that make sense? So if I have x times x under the radicand, then I would pull 1x out. Okay? All right, look at this one. the square root of 48, but what would multiply? But I'm looking for the biggest perfect square. But 24 is not a perfect square. What are your perfect squares? 4, 9, 16, 25, 36, 49. You'll see what I'm saying? So you're looking for your perfect square. So 16 is a perfect square. So 16 times 3. What is the square root of 16? And then leave the square root of 3 under it. This is algebra. All right, what would I do here? What could I pull out first? Okay, so the square root of 25 is gone. Do y'all agree? All right, what do I have left? X times X times X times X times X. I can group them together. So it would be X squared. Because basically I would have 5 times X times the square root of X. Well, that's 5X squared times the square root of X. Okay, are we good? Okay, go to the bottom. How do you multiply radicals? You simply multiply what's underneath. So what's 6 times 6? So I have the square root of 36. Is that a perfect square? What's the square root of 36? We literally just did it. All right, 7 times 7 is? So I have the square root of 49, which is 7. Okay, when you are multiplying radicals, the stuff on the outside just stays on the outside. So I would have 4 times the square root, and what would I do here? 3x times x. 3x squared. Is the 3 in its simplest form? It's not a perfect square, right? So I just leave it alone. But could I pull something out there? I could pull out an x. So I have 4x times the square root of 3. You're basically just pulling anything out of that radicand that you can. All right. Can 3 be multiplied by anything over here? No, because it's outside. You can only multiply it by what's outside. So 3 times the square root of, what's b times b to the third? So I have 2b to the fourth. Is the 2 in its simplest form? Yes, so that just, I leave it alone. But I have 4 of these, so I really have 3 times 2 times b times b times b times b. So these can come out. 3b squared times the square root of 2. Okay, that should be your multiplication sign right there. So can the 3 be multiplied by anything? It's outside of it, so 3 goes in the front times the square root of 7. What's x squared times x?
2x to the third.
X to the third, x cubed. Okay, is this 7 in its simplest form? Yes. And what could I pull out of this? X squared, x times x times x. I can pull out 2 of those, so I would have 3x times 7x. One of them got left.
Would it not be 3x squared?
Nope, because look, I have 3. I'm going to go up here. I have 3 times the square root of 7 times x times x times x. Those two just make 1 out there. Does that make sense? That one gets left. This should be a multiplication sign. Do y'all want to try this one on your own?
Yeah.
Draw it out the long way if you need to. Okay, remember 2 of these can get pulled out to make 1 out there. So what can I pull out here? 1m and 1n. So I have 2mn square root of 5 with this m left in here. Are we okay? Okay, now we're going to use the quotient property of radicals. Basically, if you have a fraction, you can do the square root of 13 on top over the square root of 100 on bottom. Is the square root of 13 in its simplest form? Is there any perfect square in there? No, because I can't multiply. What's my first perfect square? 4, right? 4 can't go into 13. And then my next would be 9, and 9 can't go into 13. Is 100 a perfect square? Okay, so I have the square root of 13 on top, but 10 on bottom. And what did our rule say? We cannot have a radicand as a denominator. Did it say we couldn't have it as a numerator? No. So you can have it on top. All right, how would I write this? The square root of 5 over the square root of 49. Does 5 have any perfect squares in it? Nope, so I leave it alone. And what's the square root of 49? All right, the next one, how would I write this? Square root of 7 over the square root of x squared. So I have the square root of 7 over the square root of x times x. There's 2 of them, so can I pull it out? Yep, so I have the square root of 7 over x. Okay, the square root of 11 over the square root of d to the 4th. That's the square root of 11 over the square root of d times d times d times d. So I got 2 of them I can pull out. So if you want to see, I have the square root of 11 over d times d, which is d squared. Okay, this is the last part we're going to do today. It's called rationalizing the denominator. What does that even mean? So everybody look, what did the rule say? You cannot have a radicand as a denominator. So what do you do if it's in its simplest form but it's a denominator? You want to get rid of it. To get rid of it, you can multiply. Y'all know anything divided by itself is... So can I multiply this by 1 and it would keep its value? So let me ask you this. Could I multiply it by the square root of 7 over the square root of 7 and it would keep its value? What's the square root of 7 divided by the square root of 7? So did I change any values? Are y'all with me? Yes or no? So how did that get rid of it? Well, what happens is you multiply straight across, yes, because it's a fraction. What's 5 times the square root of 7? Well, 5 times the square root of 7. What's the square root of 7 times the square root of 7?
14. Square root, 49.
The square root of 49. I thought you said something else.
said 14, then I said 49.
Okay.
So I was adding them.
So what is the square root of 49? Did I get rid of it? Yeah. Could you check to see if they have the same value? Yeah, look, I'll show y'all. If I go to my calculator and I put in 5 over the square root of 7, there's my answer. Let's try this one. 5 times the square root of 7 over 7. Did they have the same value?
Yeah.
So I did not change any values. All I did was put it in its simplest form. Make sense? Again, how do you get rid of a radicand on the bottom of a fraction?
Divide by itself.
Multiply it by that square root, the square root of 6 over the square root of 6, and it will get rid of it every time. Multiply straight across. 7 times the square root of 6 is 7 square root of 6. What's the square root of 6 times the square root of 6? The square root of 36. And then I can get rid of it. Oops. Seven square root 6 over 6. Does it matter if it has a variable in it? No, you're going to do the exact same thing. Multiply it by this over itself. So times the square root of 3b over the square root of 3b. It will get rid of it every single time. The square root of 2 times the square root of 3b, what do I do with those? Multiply them. What's 2 times 3? So I have the square root of 6b over the square root of 9b squared. Okay, is this in its simplest form up here? Does 6 have any perfect squares in it? No, so I just leave it alone. The square root of 6b. Does 9 have a perfect square? 3. Does b squared have a perfect square? I am posting these notes if you need to watch them again. What would I multiply this by to get rid of the radicand at the bottom? The square root of 5a over the square root of 5a. So I would get on top, what would I get? The square root of 15a over the square root of 25a squared. Basically what you're doing is you're making it a perfect square on the bottom so that you can pull it out. Okay, there's nothing that can make that a perfect square, so I leave that alone. What's the square root of 25? What's the square root of a squared? Try this one on your own. It's easy. Check your answer with mine. Could you have a 1 out front if you wanted to?
Yeah.
Sure. Okay, try the next one on your own. You shouldn't be looking at mine until you're checking it. You should have gotten the square root of x over x. We've got two more. This is supposed to have a fraction line right there. What are you going to multiply this one by?
2x.
Just 2x?
Square root.
The square root of 2x over the square root of 2x. Multiply straight across. 3 times the square root of 2x is 3 square root 2x. The square root of 2x times the square root of 2x is the square root of 4x squared. So I have 3 square root of 2x over 2x. How would I simplify this? Square root of 4 over square root of 52. So what am I going to do to get rid of that square root of 52? Multiply by the square root of 52 on top and bottom. What's the square root of 4? I'll just pull that out. 2 times the square root of 52 over 52. So your homework tonight, you're only going to do 1 through, I think, 18.